A balloon with mass m is descending down with an acceleration a, where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration a? Okay. Assume this is one balloon with a mass m and it's moving downwards. Basically, with the it's moving downwards with the acceleration a. Basically, when it is moving downwards, the upwards thrust force, that is FTH, and the downward force, it is m into g. Then we can write this one as mg minus FTH is equal to mass into acceleration, that is m into a. Then in case 2, if I am going to remove some mass from this one, that is m minus delta m, then it will moving upwards. The acceleration will moving upwards, and then the thrust force, it is moving the same, that is upward force, and here m minus delta m times a. Then if I am going to write this one in terms of equation, that becomes upward force, that is thrust force, minus m minus delta m times g, which is equal to m mass into acceleration, that is m minus delta m into a. Then I can get cancelled here forces and mg and this m. Then I'm getting the value, that is this remains constant, that is delta m into g. Delta mg is equal to, that is ma and m into a, that is 2 times ma minus delta ma. Delta ma. If I take the minus delta ma to here, then this becomes delta mg minus delta ma is equal to 2 times of ma. Then I'm going to take the common factor is delta m into, that is g, this minus will become, this becomes plus, then g plus a is equal to 2ma. Then the delta mass is nothing but the mass that I am going to remove from the balloon. Then delta m is equal to 2ma divided by g plus a. This much of mass I am going to remove from the balloon. Then our right option is delta 2ma divided by g plus a. That is option A is the right answer.